Hello. Is this stream number 37? And why the heck am I streaming so much? I think I just want to get through some of the stuff. This won't be a very long stream, maybe only a couple hours. I really don't want to stay up as late as I did last night. That was a disaster. I do want to make sure I fix assignment increment decrement. It's when we assign to an index of a local. So I'm gonna just copy the accumulate test I made, and we're gonna move that into a accumulate assignment, right? Yeah, here we go. Assign to vector component. So I think that's just that, and we should get that for the answer. Oh, okay, it's fixed. What's done again? Alt D. Alt D. Done. Okay, increment. Copy that, go to increment. All right. Go to the end, paste. Increment vector component. So that's plus plus, right? So that should go to 2 and 2. Cool. Okay. I need to start using these bookmarks. Decrement. Decrement. Okay. I was trying to think about, do I have like a key that brings me to the top of the whole file? And I don't think I do. Those keys aren't, oh. That moves the page up without moving the cursor. Interesting. So what does this key do? None of these keys actually do what I want. Okay. All right. Anyway, decrement. So that's negative, negative. So I should get a 0. Actually, what happens if I decrement and it underflows? Should get like an error for that, right? D, D, and D. So we're done. Yeah, I don't actually know if I have a test for that. Let's see, decrement. Oh, I do have an underflow. Yeah, there it is. It's an underflow. What does it actually print nowadays? Underflow decrementing unsigned integer. Now this is wrong, right? What we're printing for the current module is wrong. I wonder if there's a way I could fix that. Can't think of it right now. Okay, so moving on. We have a test for this, right? We can extend the vector but not fill its holes. Actually, that's a vector component. But actually that raises another question in my mind. Test that we can extend vector locals using assignment. And also test that we can fill holes using assignment. Vector holes. Oh, the other thing I need to do, it doesn't need to be done immediately, but support map lookups. Also support like map assignment. Well, basically map L values. Assignment, accumulate, etc. I think we support this already, but I'm not positive, so I want to test that. I do want a smaller test. How about I take this smaller test first? This is already a big enough test. I'll take this really small one. That's what I'll do. I should probably, before I do this, I should probably see if maybe I already have a test of this. Vector add equal. Yeah, I don't really have it. So we're going to call this vector extend with assignment. Okay, so my idea is that we should be able to say like x 0, 1, 2, 3, 4 equals lulls, right? And that should create holes so that, let's see if I can fill a hole by assignment like this. And actually, what happens if I try to fill it with a nil and, well, let's put a 5 there and put a 4, make a 4 equal to something else, like 10. And we're going to return x, I guess. Yeah. So we should not have an error. Looking for something simple here. Okay, I'm just gonna take this. Whose value should be 69, 42. 0, 1, 2, 3, 4, 5. Okay, so I expect that 2 will be none. 3 will be none. 4 will be 10, and 5 will be a string. Hey there, Vincent. That's a 7. There we go. Try my best. Lulls. I think this will already work, but I just wanted to have a test to make sure. It didn't work. Index 5 out of range for x5. Okay, I kind of want that to work. Because x being a L value, right? Yeah. So out of range. Okay, that's in vector index range check, right? Why does the dog want to come in here? I think the dog needs to go out to use the potty. I'll be right back. You go potty? come in? Okay, come on. I don't know why your dog wants to come in. Come here. Come here. I guess she wants to say hi. Say hi. Say hi. Come here. Come here. I don't know why you wanted to come in here. I don't have any food for you. Alright, whatevers. Dog was like at the door, like looking and going, woo, woo. I'm like, okay, you can come in. Okay. Let's put a breakpoint of bookmark there. I don't need this anymore. I should have put a... Should be better at this, right? Put a bookmark there so when I run this, I can get back to it later. Index 5 out of range for x5. So that's the path one, right? Yeah, this one. Why am I printing something different down there? That's a good question. Why am I not printing that here? Length equals 2. Okay. Yeah. Okay, so this is used for in two different places, right? Yeah. Dereference and a walk index path. Okay, so I'm kind of thinking that vector index range check, we should have it optionally extend the vector, right? Maybe what we do is we pass in, well, if I pass in an option, then the negative index check won't work. So it sort of needs to know the length. Hold on a second. All right. I'm back. Thank you for holding that shade, dude. You know what I can do is when only if it's negative in the other place would we need to check, right? Yeah. Yep. So here, I would say if index is less than 0. So let's let in, can I make index mutable? Really can't, right? Well, I can do this, which I don't really like to do, but that's okay. So I can say that. Whoops. So now it'll only do it if it's negative, right? If I... Incompatible types. Oh, I have to do that. Okay. So now it will work, but it will actually, this will cause it to crash, right? So we have to actually extend it if that happens. Yeah, we get a panic, index out of bounds. So Rust does a little check for us. So I think what I want to do is I want to say while index is less than values.length. Now, while it's greater than or equal to, right? Values dot push or push, right? None. So that will add holes in there. And then it makes it work. Great. Cool. That's it. We did it. Make sure I didn't break anything and everything passes. Cool. So test that we can extend vector locals using assignment. Done. We can fill holes. Done. I don't feel like doing these now. What I'd like to do is start work on the actually what I want to do is add this back. I want to get the grammar to work again with the C++. So hold on. I guess that means the best thing to do would be to actually run this. And then just keep going until we can actually fix the grammar. It doesn't like this, right? So the old syntax would be to do a local next. Actually, let's get rid of image. And here we'll do local next. Ignore it, and then save it to next. Okay, it's 76. So this would be what? Negative plus look ahead? Look ahead. Oh, it was right to look ahead. Do I need it to be declared as a local? Let's declare it just just in case. 96. Okay. Okay. All right, make sure it actually parses all the way. It does not. It stops after one data block. Oh, we need to look ahead. There it goes. Okay, cool. Fixed it. So now I need to make the new grammar work with this. So that's cargo run, this one. So here, plus unexpected. So we need to allow a plus to go after the this is backwards compatibility. Backwards compatibility for the grammar. Need a plus to be able to go after the ID. So I think what I'll do is I'll just make another statement for that. So we'll select this, backwards compatible. Look ahead. All right, so looks similar to this, right? Only this was a minus. And this is, there's a plus right here. And then there was opposite sign, right? So that's an ID. Or is it op copy? I can't remember what it was. It's opposite sign? Yeah, arrow and then a reference. That's an L value reference then? I thought it was an ID, but I guess I'm wrong. So it's a reference. Okay. So then I also want to have one without a plus. Ignore with optional copy. It's gonna stay up, not gonna happen. Good night. Night shade, dude. So in this one, there's no plus. So I think we're gonna have an op assign here is none. And on all these ones, we'll have an op assign. So that's an optional reference, right? This is also an op assign none. Okay, so I have to go to where we define statement. Parse statement. Okay. So pub op assign. Option reference, right? Okay, now where was that printed? That's after the, yeah. It was right here, right? If let some assign equals op assign, right? F arrow assign. Cool. So try that again. Grammar problem. Wow. Okay. 2 goes into 1. Problem arises after having observed the following symbols in the input. Span statements minus. At that point, next token is an ID, and the parser could be proceed in 2 ways. First, it could be production rule on line 214, which are consumed in the top 1 tokens and stack and produce a goal. This might then yield a parse tree of minus ID is a goal. Oh. Alternatively, parse or could shift the ID and later use it to construct a statement. I can add an annotation inline to the definition of goal. Huh. Didn't know there was a way to do that. Okay, let me check this out. So let's comment this out and see. Okay, didn't like that. It's okay with that. It's thinking. Okay, it really doesn't like it when I introduce either of these rules. I'm guessing it's because goal, like, I think that's it. That it's ambiguous then. So how about for now I just remove I remove the minus from goal. There we go. I've removed it. Okay, that was it. Okay, so we're using the backwards compatible rules for now. Oh, yeah, I need to fix that. I think actually, hold on, let me think about this. I don't, if I put minus back in, hmm. Yeah, I think we're just gonna leave it the way it is, but I need to have, what is it? Goal has to be filled in here for here. So goal, parse, I can't remember, what is it called? Goal. Parsing goal. Ignore, right? Or look ahead. And this one is ignore. Okay. I have to use that opposite though, so I guess I'll make a test for that. But I need to mark it like we're gonna remove it because I want to deprecate it. Okay, so part it's gonna be part with opposite. So the idea here is that you have something that you normally would ignore, but you have an arrow to store somewhere else, like bar, and we'd have like a local bar, and we would get the 4 bits out of bar. So return bar. So we should get exactly that out of it, right? Well, actually, that's exactly what I want. So this won't work because bar will be nil. Oh, you know what? I just noticed we have 12 errors. One thing is that I was gonna like examine how much work it would be to move nil into data value as a variant of the enum and then not have option value everywhere. I wonder why it's taking so long to build. I guess while it's building, we'll just fill stuff in. Why is it so confused? That's just opposite, right? Okay. There, I fixed it. There, I fixed it again. Nil for the win, yeah. Oh, how many places do I have this? Is it all in all these tests? What a pain. I guess there's only 8 left. We're just gonna power through this. Power through it. Here we go. I'm not going to bother having a parser unit test for it because I plan to obsolete this or to deprecate. I plan to deprecate this. This is only while I want to like keep the C++ version around to like compare. I'm curious to see how well it performs in comparison. Okay, so that's done. Build it. Build. There it goes. Okay, we failed in that new one, right? Part op assign. Yep. We got an error. Oh yeah, that shouldn't be an error. Not an error. It's none. Yeah, so it's saying that bar is none. Actually, I don't care about bar. Oh, let's get rid of this. This should be foo value. Why do I have this twice? Yeah, we should have one, but we have none. Okay, so I think this is not too hard. I just have to go to statement in ingestion where we're executing a parse statement, right? And at the end, at the very end, if it's not an error, well, before the reflection of errors, we would say actually before even this part, right? Right around here. Actually, this does the storage, right? Add a part. So it's after we do this, optionally make a copy of the parts value into a local. Okay. So if let sum assign equals statement dot assign, op assign. So we need to dereference it first, right? So let local equal self dot dereference or create local assign. And actually, let's do well, I don't want to do an early exit, do I? What if we can't assign it? Do I fail the whole thing? It's sort of a, Yeah, let's make this a subfunction. So this would be like if, how does this error flag getting set again? I don't have to think, I don't have to do too much work for this. Yeah, so I don't want to do too much work here. We're gonna remove this anyway, right? So let's just do a match. If let Okay, local. Else error equals true. But that does a okay. Dang it. Okay, we need to do match because I get an error reason out. I need to build. Okay, so this is the message, and we actually want a diagnostic log of that and all that good stuff. So error that and self on error message. Okay, and then for okay, it's a local. Yes. I can't update local. Oh, crap. Okay. Allow it to be mutable. So with the local, I want to make a copy. So this needs to be mutable, right? What type is that? It's already mutable. So local equals or local dot. Oh, we just assign it. Part dot value dot clone as ref. Come on, man. Cloned? Ah, okay. Cloned. It's moved. Oh, we did move it, didn't we? Crap. Yeah, we moved it over here. Problem is if we do the assignment before we do the storing, I could allow something illegal to happen where like you name it X, but then you store in X, and then it'll get an error because it's occupied. Well, this will actually it's only for this syntax, right? Then it actually doesn't matter. I can do it before we move the part in. And actually that makes it a little bit nicer because I can actually put it in part error, not error, and this can just be like that. Okay, so then part error can be set to true there. I just have to make part has to be mutable. Okay, and then we're good. All right, so okay, did not put a bookmark. That's not where it was, right? It was part. Ha. Run that test. Cool. Okay, I fixed it. But the ignore test is broken. What's it called? Test goal ignore. Oh, there shouldn't be a line there. Oh, right. That's temporarily removed. Okay. I should put a to-do there to remind myself to uncomment this. Uncomment once backwards compatible grammar is removed. Okay. Cool. So let me make sure I can parse all of the old grammar with the new tool. So that's cargo run again. Plus unexpected. On 96. 96. Oh. If I do that, it gets ignored, right? And then we should be fine. Okay, and then the old one still works too. Cool. All right. Good. Yeah. I want to make breaking changes, but I want to actually do a performance comparison before that. So this is the old tool, and I want to have the new tool like generate the same kind of output. What's it actually printing there? Warning, there's a warning. I have to do a two greater than and one, right? Oh, it's skipping bits, right? Yeah, that's on purpose. Okay. So I want to do that and go to old. Whoops. Find warning. So that it doesn't capture, for some reason that doesn't capture the I have to put that before the 2 1, right? So redirect to out.text and then redirect 2 to 1. Actually, it shouldn't matter, right? Well, it did matter, I guess. Okay, that's delete that one. It should be old.text, not out. Okay, so here's what the old tool output. I kind of want the new tool to output the same thing. Okay, so it's like offset and then a placeholder for bits and then size and then placeholder for bits. And this is in hexadecimal. And then the path and then equals and then the value. Okay, and that's for every bit. Or every time we parse something. And if we're in a vector context, we want to print out that context. Okay, so I think I need a main program that does this, and then I need a callback. What's this? Oh, this is where we get warnings. Extra bits, right? Yeah, we got a lot of. We're gonna have a lot of those. Because I essentially want to have the input and the output be the same for both the old and the new tool. So we're going to keep that, and I guess we're starting a new project called ingest, right? For ingestion, because that's what I had planned. I had ingest, a thin shell to test breaking down binary data, so let's do that. And I'm going to want a callback, because the way that that old tool works is it prints out a line whenever there's a something parsed, right? And it's like a parse callback kind of a thing. It takes it just a little over 1 second to parse the GIF file. I'm kind of curious how long it takes if we redirect this to null. Actually, I can do that, right? So first, this redirect it to dev null, right? And then I put the word time in front, I think. How do I go to the beginning of the shell? Oh well. Oh, there we go. Time, right? Why did it print all this junk? Anyway, it's 0.64 seconds, right? 0.63 seconds, 0.63 seconds. Okay. So let's make the ingest tool. So new directory. Ingest. Hey, let's copy from parse. Let's just copy the whole thing. Copy, paste, and call it ingest. So I need the Lexer, the parser, and the ingestion library, right? Probably need all those things. And do I need utilities? I don't know, but probably. I don't know if I need AST. I don't think I do. Okay, so yeah, let's delete that stuff. So how does the old tool work? It takes 3 arguments: format, binary, data file, format, data file, and format file. Okay, so I need to organize this the same way, right? Format, right? And this is like data path, and this is format path. Okay, so what's the actual beginning of this say? Nothing. And at the end it says something, right? It says decomposition complete done for some reason. I mean, we'll just make it say the same thing, right? So am I doing with print line? I kind of like the idea of using the logger, so we could do like an info. Okay, and then we're getting rid of these print lines. And I'm not doing any of this stuff, right? Okay, and we're not using print statements or print statement or any of that stuff. Okay, and before I get any farther, I need to actually bring this into the workspace. Ingest. All right, and then Rust Analyzer is going to take a look at it and probably say it's just fine. Except for this path is wrong, so this should be like format path, right? So we get the formats out of the format path. I hit say, okay, and then we need to import info. That's use log info. Log doesn't exist because I forgot to pull it in. I don't know, is that 1.0 right now? No, 0.4. Why hasn't that gotten to 1.0 yet? Who knows? Okay, we don't need that. We don't need IO. Actually, we probably will need IO, but not standard IO. Actually, I won't need write IO either. We're going to need to, we need to make a bitstream for files. Or I could just read the whole file in. Is that cheating though? Depends how the C++ one is designed. So decompose, right? How does that work? It uses bitstream file from decomposition. Decomposition bitstream file. How does that implemented? So there's a buffer. Why is the buffer only 8 bytes long? Okay, opens the file. Length is this file size times 8. There's a cache length. 8 minus offset. Okay. So it's no more than 8 bytes that it reads it at once into the buffer. So I should probably do the same and like only buffer like 8 bytes at a time. Why did I hard code it like that? Why do I have like that? That must be for testing or something, right? I don't know why I did that. I don't know. Yeah, but why did I put a 0? Oh, I see. It's to figure out if it's little endian or not. Okay, yeah, that's a little hack there. 1.0 incoming. Yeah. Okay. Let's make another file. Bitstream file. Bitstream file. Okay, and where is it? In I'll probably end up putting it into the parsing library, right? Or where did I put it? Where is bitstream buffer? Is it just ingestion? Buffered bitstream, that's what I called it. Okay. Bitstream file. Paste. So this is called bitstream file. Okay, and then it has it doesn't have a lifetime anymore. It has its own 8 byte buffer, and it has an offset. Should I just? I think I should just have that other file, this bitstream file. Like, I should be looking at that while I'm doing this, right? I have a buffer. I have a cache. Uint64 cache. Why do I have both? Why do I have both? Cache is the number of bits in the cache. Oh, okay. Why did I do it this way? So when we get the offset, we have to go to and ask the file what its position is, multiply by 8 to get the number of bits, and we subtract the cache length. So it's like we read from the cache first. Okay. But this is just like the cache is pointing into this buffer. Why did I do it this way? What's little endian actually used for? I don't use it for anything. I have it and I don't use it. I don't know why I have it. Hey there, Code Spent. How are you doing? I'm doing okay. So input doesn't exist, right? And then I actually don't need to record. Yeah, so I think the idea was that I was going to have a file object, and I don't think I need this buffer, right? Well, I do read into it, but then it looks like what I do is I copy. Okay, I use that for the file, but then I copy it into the cache. Why am I only reading 1 byte? I don't understand what this does. Because this, it's the number of bytes. Whoops. This is, that second argument's a number of bytes, right? So why would I only read 1 byte into the buffer? And then why am I shifting up 64 minus cache length? I don't know. Oh, it's just it's getting the last bits, I guess. Okay, yeah. So if we go to some offset in bits, then we're going to the byte that's in, and then however many, like, if this is divisible by 8. Wait, 8 minus the offset? That's an odd way to do it. Shouldn't it be 8 minus offset mod 8? Minus offset. This doesn't look right to me. Isn't that going to underflow? I think that's a bug. I think it should be like this. Right? I think it should be, hey there, Great Jack. Why did I write it like this? Do we get the same answer, I guess? It's just an odd way of doing it. Okay, anyway, yeah, like the cache is going to contain the bits up to, no, the bits that are left in that byte that we're at the position of. So if offset's divisible by 8, then we would get no bits? No, it would get 8 bits. Maybe that's why I have an 8 minus, and then mod 8. It's a weird way of doing it, though. We would get, we would have 8 bits, and so we would shift this left 64 minus 8 bits. So we're putting in the most significant bits of the cache. And but why? Why only read 1 byte? That's weird. Isn't that weird? So I think the way I did this is first we read them from the cache, and then we fill the cache from the file, and we repeat until we get all the bits that we want. So reading from the cache is shifting around a bunch of junk, and then reading from a file, it's figuring out how many bytes we want to read and read that many, and it's up to 8 bytes at a time. And we the cache is always empty at this point, so we start filling 1 byte at a time, and then we shifted up the number of bits that to put in them upper bits. Okay, I can do the same thing. So I hardly ever use the file stuff from Rust, so I'll need to learn this again. File. How do we get like a file? Here we go. An object providing access to an open file. So how do I open one? It's file create. That's what you should write to. How do I open a file? Is it just file open? Test to open a file in read-only mode. Okay. All C++ is weird? Yeah, it is kind of weird. So, yeah, we'll have a cache, just like I had in here. Because I want to do an apples to apples comparison, C++ versus Rust, right? So I kind of want to do the same thing, a cache and a cache length. This is U64, this is cache length, U8. I don't think I actually need that buffer though. Because we could just have that on the stack. I don't need that. Um, and I never use that little endian flag either. Okay. But don't I need to track the offset? How do I track the offset here? Get offset, what does it do? Oh, it just gets it from the file and then, okay, okay, I can do that. The position is the position in the file, then go back the number of bits we have in the cache. So we need a file, and that is of file. Okay. So this would be new file, cache doesn't matter, cache length is 0, right? I'm not going to do the weird thing where we initialize it with 1 byte because I don't see the point. For a very specific way to open a file, you use a file options to have a builder pattern to configure how to open a file. Okay. We'll just have it be provided on input. So delete this. Yeah, let's just delete all this. We'll do a clean implementation. So bitstream comes from ingestion. Implement missing methods. Okay, so offset is self.file. How do I get its position? Oh, I don't know. Oh, I remember this. You have to import traits or something, right? Like seek to get the stream position. So seek comes from where? Standard IO seek. So use standard IO seek from as underscore. And then I can do a seek, right? Yeah, stream position. And that is a result U64. So I guess we'll just panic if it ever can't. And then we get a U64, right? So then as usize minus self.cache length. Why can't I do that? Oh, that should be a usize. I don't know why I made it a U8. Okay. Is that immutable? Okay. Then I need to put it into a ref cell. Because the interface requires it to be immutable. So jail it. Okay, so this will be borrow, mute, and unwrap. Well, borrow, mute just gives it directly. Why did I unwrap before? I don't remember. Okay, set offset. I think what we do there was we just throw away the cache, right? Oh no, it was this has to be times 8, right? This is that times 8 because the position is in bytes. All right, so then let I guess cache size. Well, self dot cache length equals offset mod 8, right? And then self dot file dot borrow mute dot set seek. position is a seek from. Start, and that's offset divided by 8 as a U64. Unwrap. Okay. And then if self.cache length is greater than 0, then I actually have to read in a byte, right? So let mute buffer equal 0 U8 1. Okay, and then self.file. Actually, why don't I just borrow a mute way out here? Let file equals self.file.borrow mute. Then I can just say file dot file dot read. Oh, for that I have to import read, right? It's weird that I have to bring in these traits to actually use the thing. File dot read. Pulling some bytes does not provide guarantees of whether blocks it will typically. So I want to do like read all, right? Because I want it to block until, or read exact. Fills many bytes to completely. No guarantees are provided, but the contents of the buffer is called. So why is it not at the top? Yes, so if it encounters any, well, it shouldn't get to the end of the files. I'm not going to worry about that. Yeah, so it's just read exact into my buffer, please. Unwrap, right? Hey there, Sir Skull Legend. You're on stream. You're on stream because of the chat right up there. See that? Yes. You are a /user. Boop, doop, doop. This needs to be mutable. All right, so what I want to do with that is I want to, like the C++ implementation did, I want to push that into the upper 64 bits. And I think I remember why. But yeah, well, actually it's just self.cache equal buffer 0 as U64, shift left 64 minus self cache length. Right? So the cache length is 1, it was shifted 63 bits up to the top bit. Yes. Okay, I think that's all I need to do. So the length here is always going to be self.file.borrow.length. Is it how I do it? Is this bytes? Nope. It's not set length. Is it, do I have to do seek and then stream position and all that? Self dot, well, I can just do this again, right? This is how you do it in C's. You have to seek to the end, you have to get the position, but I don't know if like there's an easier way. It would be like file dot position, stream position, result U64. So that's unwrap as usize times 8, right? Because it's in bits. Okay. Hold on. That actually, that actually moves it. I actually want to put it back, right? When I'm done. So let position equal that position, and then let's first get the let offset equal self dot offset, and then when I'm done, I'm going to seek back to that, which would be set offset, right? That clears the cache. So really, it's self offset plus self dot cache length, and then we seek back to that, right? Seek position start is offset. This I need to divide by 8. Offset as U64, I think they want. Unwrap. Okay. Now the bits time. So it was a little complicated. Maybe I just copy it and port it. Because I know this worked. Porting from C++ to Rust. Well, that's let mute bits. That's the type, right? Bits equals 0. While, okay, n is greater than 0. N. Actually, we can just search replace num bits, right? N. Except for I have a local n, so I can't change that, can I? It doesn't like num bits anyway. I guess I'll rename this local. Okay, I'm gonna call it numbits for a little bit, just to get it to compile. Then we'll refactor it. Okay, I promise. So all impls turn to self dot. All cache lengths turn into cache length. Okay, this is standard compare min. So standard min becomes standard compare min. Okay, and then this size t, I don't think we need it. Right? Because these types are automatic. Auto n is let n. I don't need to cast like that. Don't need the extra parentheses. The for loop is for I in 0 to n. Okay. So for this, we're going to have a buffer, right? So let mute buffer equal 0u8 8. So self buffer just becomes buffer. And this is mutable, and this is read exact. And that's, oh, this should be n. Okay. Then this is self.file.borrow mute dot. Oh, we can't do it like that? Okay, so then what I'll do is I'll do an 8. And I'll do, why did I have a 0 there? Oh, because it was the first. Yeah, so I can just do a .n, right? Okay, and then there's no void in front. And this is just that as U64. Num bits needs to be mutable. Okay, got rid of all the compiler errors. So this, we should do an unwrap on it. All the extra parentheses need to go. Do. Okay. More extra parentheses that we don't need. What's wrong with that? It's only used index buffer, so do on take. Sure. How would I do that? Consider an iterator, buffer iter take. Okay, I can do that. So buffer it. Well, we don't need it after this, right? So into iter take n dot, well, 4 byte in. So it's just byte. Okay, and then remove parentheses. Remove excess parentheses. This is just bits. Okay, and then I think we're done then, right? It's just this isn't used. So gonna take this n and rename it. Bits. No, this is like that's the bits that we want. What do we call this? N bits? Loop bits? How about loop bits? Loop bits it is. And then num bits is just n. All right. Don't need to test it because we tested it in C++, right? So I'm gonna make a new one of these up here, right? So let file equal file open args.datapath unwrap. Okay, what are the default file options? We don't know. In read-only mode, that's fine. What are those read options? Or open options? I mean, I'm not appending or creating or doing a new or truncating or any of that stuff, so I think the default's fine, right? Okay, so then let bits equal bitstream or bitstream file new file. Okay, and then we just ingest, right? So let data or yeah, data equal ingest I don't remember the order of this. It's in the lib of ingestion. Ingestion. I have to make one of those. Okay, I should just not try to guess and just look at my test did this, right? There was a ingest. API new ASTs ingest. Okay, so that's this, right? Yeah, cool. Copy, paste. So let origin equals bitstream, subset new bitstream. No limit. Make a data component. The format comes from args. Some origin. No arguments. API new. ASTs ingest composite. That's let data equal that. All right, bitstream subset. Is that private or something? Hold on. This is ingestion, right? This should be formats, I think. And we borrow it. Cool. So how do I make one of these composites? So the API needs to actually expose this. I hope it does. It does not. So we have to do that. Why can I not do that? Oh, because it's the wrong thing. So that's pub use API that. Okay, and then I mean it's public, so why don't I expose it? Right? Okay, and then don't I also need the bitstream subset? Well, that's exposed through here, right? No, it's not. How do I? It's in component, I think. Yeah, this bitstream subset, where is that? That's in ingestion. Okay, so bitstream subset. That needs to be exposed at the lib level. Right, it's not. So bitstream subset. Now it's exposed. So I should be able to import it. Yes. And that. And that. So I need to put it into RC ref cell for it. Okay, so RC new ref cell new bitstream data. Okay, that's RC, that's cell. And it wants a reference to it. It's still no good. It needs to be static. I don't get it. How did I get this to work on the unit test then? Oh, it's a dyne bitstream. Uh, yeah, the type is wrong. Right, I remember this. I had to do this like this as bitstream or something like that, right? Or dyne bitstream. I forgot how did I do this? I did this in a funny way somehow. ingest, fine, show call hierarchy. Here it is. As RC ref cell. Okay, that thing, right? I had to do that. Outside of the RC. Okay. So delete that and then do that. That. Or actually, well, this has to be imported, but that erases it right away. But if I wanted to keep it around, then don't I do this? Type erase it right there. Can't do that? But I could erase it this way. I could say that bitstream file, and then I could make bitstream is bitstream file as that, right? Dot clone. So I make a type erased clone and I give it to them. If I wanted to retain the original type. Not that I really care, so maybe I don't care. So I guess we'll just erase the type like that. Okay, so we get the data, and that should do it, right? Except for we want to set on error and on yeah, just like the test do on error callback, and I wanted to make a new callback too. How do I do that? It's in here somewhere, right? API. This actually doesn't do it. What calls with error callback? Find all references. Oh, I do it if I want to explicitly like that. Okay. Fine. Yeah, and I remember doing this. I had a channel that I would use. And the reason for that was ownership, right? Because I'm letting one thread go. Well, actually, I think I just did this to be so I didn't have to give yeah, oh okay. Because this callback, this optional callback is a boxed mutable closure. Actually, I can just have it that's easy, right? I can just do that hold on. Here. I can say with error callback and then just do it here. So we get, what do we get? Okay. Path. We get that. That's what we get. So what should we do with that? I think we should just do error. Path. Value. Like that. Well, errors are redundant, right? So that comes from log. And actually the tidy types are implied, right? I don't actually need to say them. Maybe I do. Mismatch types. Arguments are incorrect. Wait. Does it supposed to, am I supposed to return something? Oh, I need to box it. Okay. And it needs to be sum. Okay, so this to be box new that. And I need to put sum in front, right? Doesn't implement the display trait. Yeah, that's the problem. Like, I hate this. I'll have to fix this. So if let some value equals value, else um, nil to string. And this is to string. It's ugly as heck. Okay, so I actually just want to try to run this. Cargo run. So we want to do bin ingest gif stay. Next one's the stage lull.gif and then gif.format, right? Here goes nothing. Look ahead is not indexable. Unable to parse data. Line 78. Column 5. To line 89. Column 6. Oh, all the way down here? Whoops. Oh, shoot. We're getting to that. I don't have support for that yet. That's on my to-do list. Dang it. So it's because data header, I was using a, yeah, I remember this, sort of. I formed a map, right? But I can change this to a vector and then it'll work. So what if I just change it to a vector first, second? Because even in the old format, this should work. In the old parser, this should work. Data header. So look ahead. So this should be, so first turns to 0 and second turns to 1. And I think that should just work. Okay. Bad extension introducer. Unable to parse comment extension. Unable to parse special purpose block. Unable to parse data. Well, that's a lot of errors. Bad extension introducer. Bad extension. So how did we get to here? Graphic control extension. That's if a look ahead is that. It's given look ahead. It does a look ahead of the data header to look ahead. So I think we have to print out more. So I need to add like an on part. We have it with error callback. What I really want to have is like a with part callback. And we will be, let's say that we get to borrow a data component. Okay. And we'll do an info, and I want to kind of make it look like the old format. So it was like something like this. Here's the template. So it's like 6 hex digits. So that's like 6x, I think. And then we have something else. If there's a, right, if it's like, if it's not divisible, right, that's the byte offset and then the bit offset, right? And then parentheses, another colon 6x, and then a right bracket. So there's a left bracket there, and then a space, and then the path equals, and then a value. So that's the value. Value, or this is really component parts, right? So that's part dot value, right? And we're borrowing that. And okay, so then first we got to say let, I guess if it's a part, we should always assume that it's got an origin, right? Origin equals part dot origin dot, actually I can just do an as ref, right? As ref dot unwrap, because then I get a bitstream offset, right? So this should be like let byte offset equals origin dot bitstream dot borrow dot, no, I shouldn't need to go to the bitstream. It should just be but dot offset. Yeah, dot offset. There we go. U size divided by 8, right? So that gets me a U size, and then so this should be byte offset. And then I want the bit offset. So that's going to be a special string, right? Bit offset equals if, well, first we're going to compute it. Bit offset equals origin dot offset mod 8. Okay, I need to go to bed soon, so let bit offset equals if bit offset is greater than 0 something, else something else. So the something else here would be 2 spaces to string. Otherwise, it's going to be format dot bit offset. Okay, and then I need to do the same thing for the limit. Yeah, okay. So, and that's only some of them, right? Some of them don't have a limit, or do they? They all have a limit? It's like they all do. They all do, even the overall, right? Even the overall drift has a limit. It looks like it's too big there. So we're gonna copy this, and instead of byte offset, it's going to be limit bytes. Just be offset bytes and offset bits, I think. Offset bits. Okay, and this should be limit bits. I keep hitting escape by accident. Okay, so this is limit, right? U size. Okay, got it. So don't know why I didn't rename it inside this. It's not renaming inside of the string interpolation for some reason. Okay, so the second one there is offset bits. And then the second one I'm going to have here is limit bits. Because I'm going to put limit bytes right in here. All right. Comma. Then the path and then the value. Okay, but we don't have a part callback. With error callback, let's add that. So we're going to add a part callback. With part callback on part, optional part callback. Okay. Then we'll have an on part here is none. This should really be after that. Okay. Then there. This is a callback to invoke. Okay, I actually have I have a comment for this written up in the C++, so let's copy it. Here it is. I got it right there. Go back. Cool. And paste. Rewrap. This is the callback to invoke each time a component covering at least one bit is completely decomposed, completely ingested, because we're changing the conventions, right? All right, and then that we need to define. Optional part callback. So this is going to be was it going to be a name? No, it yes. Actually, it's a path, right? Yeah, it's a path. Path string, and then this is going to be a borrow of a data component. Yeah. Okay, and then on error. So we see this in various places, right? Okay. Yes. So I can invoke this anytime I want. No, I can't. How do I invoke that error callback? It's like this, right? If self API bar, yeah, exactly like this. Okay, so where I want to invoke this is when a part is successfully parsed, I think. So that's execute part statement or parse statement. Or actually, let's see. This show call hierarchy. This execute statement, statements, maybe here ingest composite. Where was it that I was it here? I was doing like handling, like if I was doing special handling. Where was that? This is in the API level, so it's not there. Composite, custom, it's around here somewhere, I thought. No, I'm lost. Wasn't there some part where I was like, is it build part? Is that what I'm thinking? That might be it. So injustice custom, I don't know where I'm going. Just composite, add to path. I totally am not finding what I'm looking for. Unless it was here and it's just my brain is like farting big time. It might be what's going on. I think what was I thinking of? It's where we had the like part error. This stuff here. Execute parse. Okay, it was inside of execute parse statement. Is that where it was? Okay, but we don't have to. It can be above this that we do this, right? We should. Show call hierarchy. Yeah. So because execute parse statement doesn't ingest composites. So I think maybe that's where I want to do it. Yeah, it's like right here. If this, okay, so there's a return scope, right? Do I want to do like if it's not an error, or just want to always do it? Maybe just do if it's not an error. If not self composite. How come it's not letting me look at it? I don't know. It's being lame. Okay, and then I'm gonna paste in here, right? If let sum on part, then on part and get the path, and it's here we get to let it be borrowed. There we go. Okay, now what happens when I run it? Did it print stuff? Oh, it did print stuff. Look at that. Oh, I wanted to zero pad everything, and the lengths are all wrong. That's not cool. Okay, so back to main. I want to zero pad everything. That's like if I put a zero in front, right? Okay, we're getting there. So the old format looked like there. There's the new. Okay, forgot end parentheses, right? Also, this limit's wrong. Oh, I guess what we want to do is when we close a part, we want to update this limit to be the actual number of bits parsed, right? But the offsets all look good down to 8. Yep, these are all good. Logical screen color table size 255. It got the width and the height correct. Look at that. Global color table. And then it skipped something. Skipping 24 extra bits for data sub block. Oh, where that Netscape was. So that's offset 310. I don't think we got that far. Yeah, we didn't get that far. It got to the end of logical screen and then it barfed. It somehow got into a data block. Actually, how did it get to that? How did it get to offset D, not 30D? There's something weird going on. Maybe my file reader's wrong. It like backed up or something. That's what happened. Oh, also in the path, we're not printing out the indices. So 3, is it the global color table? Oh, actually, no, there's a D there. Why is that? Oh, it didn't back up. That's the whole global color table. And the size is wrong because we need to subtract from it something else. Like that's wrong. It should be 768. Actually, you know what? I think I might have messed up. That's not hex, is it? I think the limits are actually in decimal instead of hex. I messed that up in the old code. I should probably fix that because I'm gonna want to do a diff between old and the new. And it'd be kind of lame to have to like mess up the Rust code on purpose just to match the diff. Yeah. Anyway. So it didn't look, basically it didn't look ahead correctly to see the special purpose block. It thinks it's a data block. Oh wait, no, it's looking ahead. All right, it's actually figuring it out. The first one's 71, the second one's 73. So the data header's 71, 73. So it figures out that extension introducer 71. And then it says bad extension introducer. Why is it going to offset 0? Okay, that's wrong. Is that because these... This is only 1 byte long? 1 byte long. Yeah, it's going back to the beginning of the file and reading at the beginning of the file, which is wrong. Oh, I think I might know. I think there's a bug in the look ahead. I think it's actually jumping back to the beginning of the file when it to the bit stream instead of jumping back to the beginning of the part. Yeah, I remember seeing this before the stream started. Okay, so then I know where to go to fix it. But let me first fix the missing parentheses. That goes there. And then I kind of want to fix the C code. Like it's printing the wrong number for the number of bits. Like, or if we go to the end, like that's the number in decimal. That's the number in hex. Shouldn't it be the number in hex? Maybe not. Maybe I intended that to be a number in decimal. Okay, so there are a couple of the bugs. So the look ahead doesn't work. We're also not printing the like for these ones, like global color table red, it's not printing the vector context. So I kind of want to see that one. In the callback we can add it. That's where I can do. So yeah. Okay. Well, first, there's too many things I want to do. This dissector. I don't know the names of my files, so let's just go look. Definitely need to end the stream soon. Decomposition. Decomposer. Right, it's where this component complete callback is called. Okay, here it's called. Oh wait, it's where this is called, actually, where the set one is called. Find all references. This one right here. Okay, here we go. Here's the C code equivalent of what I was just doing. Oh yeah, look, it's doing it in int. But why am I doing hex digits? Yeah, I think that's a typo. I think that should be a capital X. This one right here, right? Or Well, I didn't know that we computed this on the fly. Oh, that's cool. So it's taking the data size and shifting it right 4 bits. And oh, right. So it's taking the data size and seeing how many hex digits it needs to fit that number. Okay. Well, that's more advanced than I need it to be. That is pretty slick, though. Must admit, past Raimu did a good job with that. But yeah, this is wrong because that should be an X. So maybe I just fix it now. There, it's an X. I fixed it. Is that right? Printf, the number of size divided by 8. Wait. No, it's the one on the left. There. Because it's hex digits. Yeah. Okay. I fixed it in the C code. So I forget, how do I do that? Do I do CMake build? CMake build. I just need to build the decompose. DataDisintegrator decompose executable. Actually, let's go ahead and make the release variant so that it's fair, right? So build the release variant. Okay, we made the release variant. I can turn off CMake. Go back to terminal and then build decompose. Go to, not to dev null. Go to old, right? Actually, that ran really fast. .263 seconds. 0.266 seconds. That's real fast. And all the Rust implementations. The Rust implementation has got a lot to beat. So yeah, let me see if the offset is correct now. Nope. Yeah, maybe I'm not running the right build. That's just now, right? Did I not save that? Huh. I did put an X in there. Why is it not printing it? Oh, wait, that's only if it's got um, extra bits. So if it, I have to put an X there too. Okay, one more try. So CMake build. It builds really fast too. Okay, and it updated this and should be able to go to the end. Okay, cool. So now it's the number of bits in hex like it should have been all along. Okay, so then we have the benchmark to test with. In fact, this even prints out the timestamps in it. So it takes a little longer when we're piping the output to a file. When we run it and go to dev null, it's a little bit faster, 0.263. So let's go to the main.rs. I guess we're just going to run it. Okay, so a couple things I have to fix, right? I want to fix the bug in the look ahead. I'm pretty sure I know where that is. So I think the problem is I didn't test it very well. I have this look ahead, but it starts at offset 0. So what if we like do what if we parse like 2 bits and before that we ignore 2 bits? Right? So then I should get 0, 1 for X. And the offset should be 6. Because it reads 2 and rewinds back and reads 4 more. And then Y should be 0, 1, 0, 0. So I think this is going to fail because it's going to rewind. I think what happens is this ends up rewinding all the way back, but before that. Yeah, see, it's actually only reading 4 bits total instead of 6. So if I remember right, the rewind was it in statement? Yeah, rewind. Yeah, see, it's going to the beginning of the composite, and we really want to go to the part and rewind to the part's beginning, not the composite's beginning. So I think that should fix it. Cool. Let's run all the tests to make sure they all pass still. Cool. And now run the tool. Okay, it still didn't get very far. It got the Netscape though. Look at that. Okay, so it got down to the Netscape part, and then it cannot compare as equals something to a nil value. On line 227. Okay, so what's on line 227? GIF 227. If size equals 0. Why didn't that work? It should be size is 3. Oh, it didn't do a reference in... Right, it's supposed to check in vector context. I have a to-do listed like to have other search points. So, yeah, this is a problem then. It's not that. It's not the search start points. It's the fact that it finds size, but it doesn't like apply the vector context to it. It should see that it's a vector type. Try applying the vector context to it. Yeah. Okay. Well, that's pretty impressive. We got down to the Netscape identifier. Actually, we could fix one of the other bugs in here, right? Was that it's not actually setting. It should change the limit to be the actual number of bits at the end of a composition. So I should make a test for that, right? Part maybe. So something like this, like bar, right? We don't give it a limit to bar, so bar's limit should end up being changed to the number of bits every time. So like X, I should be able to look at X's, X is ignored, but Y is not. So let's get Y. Let Y equals that. And then I should be able to assert that, well, for one thing, the beginning of Y is at 2. So Y dot origin dot unwrap dot offset. And I need to do as ref for that because we're just borrowing it. Okay, and then the limit should be 4. Or actually, should the limit be no, the limit's from the offset of its start, right? So this is where I expect it to fail. Because the actual limit is, it'll say 6, right? No, it says 8. Oh, so it's even worse. It actually shouldn't be 8 at all. It's supposed to be from the start of the part. Coming from the first bit which makes up the data of the component. So that 8 is not even correct. It should be 6. because it starts at 2, not 0. Okay, well, let's fix both of them. Do I test limit anywhere else? Final references. I do test limit. Okay, that's set correctly. Okay, so it's only compositions that are broken. The built-in ones work. These ones work. Because the original limit there is 16, and that's actually set to 8 once it's done, right? And why is that? Because that limit is set, right? Okay. Yeah, I think we just didn't test, I didn't test like compositional limits. This works because probably we didn't have anything after it, actually. Actually, no, this works because the X limit is 4. Okay. And then the Z limit is 1. And that test passes, right? Yeah, that test passes. Okay, so, whoa, that was weird. So it's just composites that don't set their, well, actually I can go and see where it's actually set. It's not in these tests, right? It's in this data right here. Doot, doot, doot. Not there. And it's not going to be there. Not going to be there. Okay, where is it set then? Hold on. Now I'm confused. Oh, it's probably set here and new. So let's go find all references to new. Okay, so context. Make bitstream subset, and the limit is limit or boundary. And then what does that do? Okay, so it's the math in here, right? The current offset minus the bitstream length is the default. But if there is a value set, then, hey there, TBA Schneider. How you doing? If there's a boundary set, it's an absolute boundary, right? Offset of the bit after the last bit within the bounds of the statement group relative to the start of the bit stream. Okay, and so actually this is a problem because that means if it's unwrapped, it just is what it is, and we're not using the bitstream's offset. I have this problem again, like where sometimes the limit is relative to the start of the bitstream, and sometimes it's relative to the start of the part. But I have tests for this. Am I not testing it adequately? Okay. It's only called from one spot, right? It's only called from here. Make bitstream subset, but this can be called from a lot of places. Only 2 places. Okay, it's called from build part. All right. And the bound is an expression. Yeah, but it has to be evaluated. Okay, we called determine limit to get that. Got it. So it's the magic's done here. So okay, we evaluate it. Limit, we can convert it to a U size. If it is something, oh, okay, then it's the offset plus the limit is the inner bound. So it is okay, so the limit is set to be the number of bits from the start of the part, which is correct. But this boundary is not correct, is it? That is not correct, because this boundary is relative to the start of the bit stream, right? Let's see what all these references. Boundary on the context, yes. Okay, and then there's where I think it's wrong. Because we need to, if it should be self-boundary minus the offset. So yeah. Anyway, where do we use that boundary? Newest part, we put it into the context. Yeah, but where do we use it? Update boundary, yeah, sure. Where's update boundary called? Okay, for the bound statement, right? Yes, so current offset plus the limit is the new boundary. We get the original boundary. Oh, it's update boundary, yeah. So we just swap it, really. Execute that, and then we get the current offset, and we make sure it doesn't hit the boundary. If it, or well, it doesn't, we don't need to check that, actually, it's checked inside. If we don't reach the boundary, we skip ahead to the boundary and say the number of bits we skipped. And then we go back to the original boundary outside of that. Okay, so it's actually relative to the beginning of the bit stream. So the documentation's wrong. The documentation for this says relative to the start. Oh no, it is relative to the start of bit stream. Okay, never mind. But that means that the when it's used, it's wrong. So I should find a test about that. This right here, this or boundary part is wrong. So this would be if, but maybe it's impossible for that to ever be, ever go into there. Let me see. So if there's an error, it sets it to 0. And so it'll be something. So it'll be if it's not an error. Can this ever be none? We have no bounds. If it's none, no value, it's still none. So the only way it'll be none is if no bound is set on it. Okay, then I think I know how to make a test. I know how to devise a test to make it this break. It would be if we parse two integers and give the first one a bound and not the second one. So this is going to be test part with no bound, non-zero offset. Okay, so it would be, we have some unsigned integer we ignore that's 2 bits, and then we'll have an actual bar that we actually care about, and we don't give it a limit, and we're going to return bar, I guess, and then, so this should be, we should get all the bits, there should not be an error, and the value should be only 6 bits long, because the first 2 bits should be eaten, and then I can also say about that it should be offset of 2. Well, this is bar actually I care about. Actually, that's all I need to test. Because if it got to bit 8 and it got 6 out of it, that means it has the correct bound on it. So I don't think this is going to work. I think it's going to fail. It passed. Why did it pass? That shouldn't have passed. I'm confused. How about I put a breakpoint and look at it? So I thought, let's put a bookmark there. Delete the other bookmarks. Okay, I thought that when we set that or self boundary here, that if limit is none, the boundary would be the wrong value. So obviously I'm wrong. Let's debug. Okay, no, the limit is sum 2. How did it get to be 2? Oh, right, that's the first thing we parse, and then hit go again, and it'll be none. Okay, and the self boundary is 8, right? So he'll have the wrong limit. If I step in, let's see what happens. Yeah, see, it set the limit to 8. The limit's wrong. So how did it actually parse correctly then? Okay, I'd be careful here not to step too far. Yeah, we want to go into ingest. So out of that, into that again. Okay, and then it's going to go into here. Okay, and so the origin is, right, offset 2 limit 8. So that's too many bits. It'll try to read 8 bits now. Bits is 8. Oh, I have a break here. That's why. The buffer bit stream was just too polite to refuse. Okay. I ought to just have it panic. Yeah, so I bet you if I put a panic in buffered bitstream where we get to here, let's call this unreachable actually. Or another way would be to assert that it's less than. Maybe that's better. Assert that the offset is less than the length. And I think we'll actually see that that assertion fails in this test. Yep, it failed. Panic on, yep, okay. So let's fix it then. That's a bad one. So it shouldn't be self-boundary alone. It should be self-boundary minus like the current offset. So how do I get that? I think I just do minus origin dot offset. I think so. No, because this has to go and figure out what the offset is, right? It has to do this current offset. There. And why can't I do that? Can't subtract it from an option usize. No, that should be a usize. Is boundary is an option. Okay, so if this is none, only if this is sum do I want to set this. So I do want to do a map, right? I want to do a map. Boundary like that. I'm missing punctuation. There we go. So limit or self-boundary dot map boundary minus the current offset. All right, now let's see if that passes my test. Cool. Fixed it. Now let's see if I want to run all my tests to make sure if I ever hit that. I did hit it. I hit it on test look ahead. How did I fail? It. Oh, that's interesting. It only read 4. No, it said the limit was 6. Oh, no, that's correct, right? Why did I have 4 there? Oh, because it should have been 4. That's a problem, right? Oh, right. That was the original problem I was going to fix. That it doesn't take the actual number of bits and limit the composite to it. So yeah, I'm back. I'm good. I'm back to the original problem of half an hour ago. So that was in context. When we ingest a composite and we're finalizing the components, and before we do this, so it'll be if self dot composite. Actually, it's one of the things we do in an error too. Well, it actually doesn't matter if there's an error or not. If it has an origin, so if let some origin mutable equals self origin as mute. Okay, then origin dot limit equals the current offset, so that's origin origin dot bitstream dot borrow dot offset minus origin dot offset, right? I guess I didn't have to say that's mutable because we're borrowing a mutable reference to it. Cool. All right, run the test again. Let's put a bookmark there. This I don't need a bookmark anymore, right? Because this one works. So clear that one. So where was it? We failed before. Test look ahead. Test look ahead. Run the test. Okay, cool. Fast passes now. Fixed it. Passed all our tests. And did it warn me about some error? What was this? Unused variable data. Here, well, how come it's not warning me about that? Huh. That's weird. We're getting a warning here, but not here. I need to restart you. Restart Rust Analyzer. It should give me a warning about it. Come on, man. There we go. We got our warning. Our warning is we didn't do anything with that data. And I think that's fine because I'm actually just using the callbacks, right? Okay, so then with that fixed, let's try parsing again. Ingest list. Okay, it didn't get as it still didn't get any further. Why is that? Oh, I don't know why it should have gotten further. Cannot compare. Oh, that's that same problem. Dang it. It's not using it if size is in a loop, then size has a vector context. So we have to be able to, when a reference needs to check vector context. So in fact, it should check all the way down the vector context stack. It should check the bottom first, really. Yeah, it should check the innermost. Okay. So that's in reference. Dereference, right? Yeah, so it's getting down into here and it's stopping. And it's just returning yeah. So there should be like implicit indices that we check. Actually, you know what I can do? The caller of dereference could do this checking. Right? I could make temporary reference. What would be better? Yeah, since it's only calling one spot. Would it be inefficient to call this multiple times? I think it actually would be. And actually, it would only be the first part that we look at. So it should be on step 0. We should check, right? So we get the first child. And let's say the reference doesn't have any indices. Actually, even if it does. No, it should be if it doesn't. If it doesn't have any indices, then we and we're okay, so it's something like this. For the first step, if there are no indices provided, and we are parsing in a vector context, I guess, yeah, look for, I guess, and if, yeah, exactly, and if the part has iterations, select, automatically select the current iteration. Exactly. So, and then this should be otherwise. Yes, so we should say if step equals 0 and this is empty. And self dot iterations is not empty. So a lot of conditions. And part dot iterations empty, not. The only problem is if it's from a previous loop, that's a problem, right? I guess what we do is try to automatically select the current iteration, right? Well, if it's in a if it has iterations, I think it makes sense to at least Yeah, it should make sense to pick it up. If we didn't want to automatically select, then we would have provided indices. And yeah, exactly. So this is actually the correct thing to do. So then I have to repeat all this junk, right? Well, no, I don't have to do all this stuff. Let's do some of it. So it's like a different kind of loop. Um, why do I have that inside of the if? Where is that used? Oh, that's if the iterations is empty. Okay, we're not looking at that. We're okay. So this would be for index in self dot iterations dot, well, borrowed. Yeah, it's almost midnight. I gotta go to bed. I want to finish this though. Come on, a little bit more. Um, do I want to do the range check? I mean, I could just do that manually, and we don't need to evaluate an expression either. Yeah, don't I just do this? So like this, right? If let some iteration equals part iterations get index, there should be no expect, right? So it should just be if let, whoa, borrowed out slice output. Ooh. It's an option, right? That is actually an option. But part is itself what? It's a reference. Okay, so it has to be something. Why is this not okay, because we have an error because I'm missing punctuation somewhere. Right there. There we go, I fixed it. That. Okay, so iteration is what? Reference to an optional component. I think what we do is we try to get to it. I guess we would want to error out, right? If we can't find it. So it would be else. So it would be let it be some iteration else. I can copy from here, right? And yeah, it's gonna try to go into there. So it means I'm going to want to add to the path. Where am I doing that? I'm doing it in one of these, right? One of them that takes the path. This one? Yes, I want to do that. So go back. And we're gonna add to the path here. And do that. Okay, so then we're indexing into the path here. We get it, or we say we can't index it. Right. Then it has to be some part equals iteration else. Then it's a whole, right? Then it's like, not that it's cannot index, but that is empty. Then, so this is what, next part equals, what do I want to call this? Part iteration. There, I think that's it. So let's try that. Bookmark. Go to the next bookmark. We fixed that. I can remove that breakpoint because we're not debugging there anymore. Remove that. This, not a problem. Oh, I never made a test to check this. I should have a test for this, right? Yeah, let's make a test. So that would be in vector. I need one with a loop. Like this. Let's just copy this one. Okay. We're going to call this one vector referencing iteration. Okay, so then it's kind of like this where we're going to parse one thing and then we're immediately going to use it for something else. So we'll say like UI y x. Okay, and then we'll return y1 this time. So the first byte will be how many bits to parse. So we'll do like 4 and then actually we'll do 8 because otherwise it's going to be hard to assemble the bits. So the 8 will be like 34 and then the next loop, actually the next loop 8 again. It has to get the number from somewhere, right? Actually, then I'll just put 12 there because we already have this that we're expecting 34 for the value. So that should get the value of the 8-bit number. And we want to make sure that it's not an error and that it actually parsed exactly 32 bits, right? 32 4 bits dot borrow dot offset. Then we're gonna get do I care about any of this? I don't think I do. I don't care about this at all. Make sure that this works. I should have made sure that this failed before. Let's put a bookmark here. And let me comment out what I had here. So like pretend we're not doing that anymore. Go back to here and then this should fail now. Yeah, it fails. Yeah, because it's reading 40. 1, 2, 3, 4. Actually, it should have given me an error that I should use X. Actually, that shouldn't have worked. It should have done a nil. Oh, right. If it's nil, it goes to the end of the bit stream, right? Yeah. So a real test would be to try to add something to it. Because then it'll say can't add 0 to nil in the diagnostic. Yeah, cannot add something to nil value. Exactly. Unable to parse X. So if I comment it back in, it should fix it. Cool. All right, I'm happy. Whenever I find a bug, I try to add a unit test. We're almost to 500 tests too. Try to add a test that replicates the problem. Ooh, look at that. It got all the way to the end of the file and it found the trailer. Cool. Look at that. And we're getting the warnings that it's skipping extra bits and everything. Do you know the VS Code extension Rust Test Explorer to list and execute test in the workspace? No, I don't. That sounds cool. Should I look into that? Rust Test Explorer. Oh, this one? Enables viewing your tests from the test sidebar. Functional was still an early beta preview. Bugs are inevitable. It's got 4.5 stars. Let's try it. Let's do this. Okay, how do I see it? Do I have to, how does it work? It should open up something here. Testing? It's not finding anything. What's this? Is that running a C++ test? Yeah. Okay. It might be confused because this, oh, is it down here? Aha. So that's, there's two test explorers. This is a C++ test explorer, which apparently is broken. I don't know why. Maybe because at the top level, I didn't ever add any C test things for the C++. Where be my tabs? Terminal. There we go. Yeah, so it's the other one. Run all the tests. What's it doing? It only ran some of them. Oh, because the other ones don't have tests. Cool. Okay, what would be even better is if it went to the source code file. And it's not doing that. Can I did that reload? Okay, run. Okay. It would be cool. Yeah, it would be cool if it if you could click on it, it should actually show where it is in the code. Okay, but you know, beggars can't be choosers, right? How does so see watch debug. Error while debugging test. Error method not implemented. Well, okay, we can't debug tests, but we can run individual tests, right? I need to actually break a test to see it not work correctly. So let's run all the tests. Oh, there it is. It's funny, I had to break the test to see it. And I can't see the test results unless that's another window. Test results? But that's the C++ test results, right? Well, better than nothing. Well, that's cool. I'll keep that. Why does it say there's one failing test? Is that from the other test explorer? Can I just like reload it or something? Can I clear that? Clear test results. I want to get rid of that one. How do I get rid of that one? It says one failing test. Can't seem to reset test states. Clear all test results. Well, that's okay. We can just hide it. There we go. Okay, well, thank you for that. Points to TB Schnei. Whoop. How did I do that? I almost navigated away. Have a useless internet point. You can't do anything with them, but they're fun. Okay, so I want to fix one problem. Is that it should have the context of what it should have the vector context in the callback. So that's on part here. Yes. So I want to have a path that has the vector context in it. And we build that path up from the context. So I need to actually make a new one here. So let mute path equals self path clone for index in self dot iterations. Path plus equal format, and we're going to borrow from it, which is sort of bizarre, but that's okay. Index. And borrow from that path. Easy. And it still didn't work. Why didn't that work? Is it because we're popping off iterations? Hold on, let me think about this. No, it should have like printed. Shoot. Do we ever get there? I can't debug, can I? Am I running the right thing? Yes, I'm running the ingest tool. Yeah, see, it should be printing them here. It should be iterating through like the global color table here. It should be printing an index, and it's not. Path plus it's a vector. Okay. Align all references. Wait. Shouldn't it copy? Oh, I think I see the problem. It should be using the composites iteration state, not the parts iteration state. Yeah, it should use the self. How do I get to that? Just composite. Okay, I'm not sure. Oh, I never tested to see if the limit was correct. It is. Look at that. The header is now 6 bytes long, like it should be. Okay, well, at least that's fixed. But yeah, I thought that that would have something in it because we're in a loop, right? But I think it might be the... Okay, well, there's a problem then. Hold on. The way this is defined... Oh, will be inside of data when we see that. It's when we come out of data that we actually want... That's what we'll actually know the context. So I think I need to move this callback. This needs to move like to the caller of this call hierarchy. So it's called from ingest. This is the outermost in the API, so not that one. Parse statement. Yeah, it's when we return out of this that I need to do it. So like right here, right before we rewind the bitstream would probably be the best, right? Yeah, right here. So we bookmark that. Okay, go back up to here. We're gonna move this then. Cut and paste. And this shouldn't be self-composite error. It should be part error. Part error. So, right, if we have a callback to report the part, then the only problem if I do it this way, the top level won't be reported. But actually, was the top level ever reported in the old format? Yes, it was. Okay, so maybe we need a special one for the topmost one. Or let's just see what it does. We might no, we don't go through parse statement for the top level, so this won't print out the top level one. But you know, that's okay. So yeah, we're looking at the at our current context, not this new it's this new inner context we were using the wrong iterations for. You know, I could actually fix this by having ingest composite take another argument. Maybe not, because then I would have to pass it from the other places too. Never mind. Let's just see what this does. Yeah, so I think it's off by one actually. GIF 0 is nil. Oh, I see the problem. It's already popped the part's name off the stack, so it should be gif.data equals nil. It's also printing the wrong region. Okay, so it should say gif.data 61 is, and it shouldn't be saying nil. Okay, the region is wrong. Yeah, it's not self-composite, it's part. But the path is wrong. The path is all right. It's not self path, right? It's the first thing that this does is it adds to the path. So actually, kind of what I wanted to do is this destroys that context that had the path in it. So this is where it was, right? So I actually kind of wanted to be there, but I wanted to know what vector context it's in, if any. Okay, then I know what I'm going to do. I'm going to put it back where it was. Oh, this was correct what it was, right? Okay, there. Okay, I need to cut it from here and go to the other bookmark. Here. Paste it back, right? There we go. Okay. But I don't want to use self-iterations. I want to use composite iterations. parent iterations. Composite iterations. That's going to be passed in now. Okay, so we now require that. And that's just a U size. So we can just pass an empty slice for places that we don't have it. Okay, so for here, this is the API level. So here we would pass an empty slice. Okay, and then in expression, actually here we could use self dot iterations, right? Actually, it's a function call though. Yeah, so it should use an empty slice because it's not going to be stored. Okay, and then here we do want to use borrow self dot iterations. Okay, and then we're done. So we try it out and see. Go to the end. It's off by 1. The other tools. Oh no, I'm looking at the wrong one. There it is. 60. Oh, we're also printing the ignored bytes, I think. Yeah, we're not supposed to print those. What's it interesting? We're not printing the ones at the beginning, but we're printing the ones at the end. Why is that? Go to the top. Oh, because it's not until we get down to here that we start doing that. Okay, so if I go down to past logical screen, I'll probably see it, right? Like if I go to look at next. Okay, I don't know where to look then. Okay, I'll just keep hitting enter. I guess we're going to 256. At least the vector context is working. Okay, there we go. Oh yeah, there we go. So we're seeing that those values we should be ignoring. That UI, which is 33. This next. Okay, so we need to look at the parse goal and not print because look at the parse goal and not print it if we're supposed to be ignoring it because the old I don't think prints that. So if I go to the top-ish, look for logical screen equal. Oh, I don't have that? Okay. How about if we look for data header? Oh, interesting. Huh. Oh, because that's also a look ahead, right? So the first... Oh, and I'm not supposed to print it if it's equal null. Right, so this should not print because it didn't print there. That didn't print. The first thing that should print is the extension introducer. Yeah. Okay, so because these are all supposed to be ignored, right? These are all look aheads. Got it. Okay. That would be under like data, right? Data. Data. Yeah, this look ahead. We're not supposed to print that, right? So actually that means, yeah, Data header doesn't know though, does it? Yeah, data header doesn't know if it's ignored or not. How do we control it in here? It's not actually printing it. It just kind of skips to it. It does parse, but then it backs up. So it somehow knows that it should be ignored. Maybe I allow that to be reported because we're going to report these data headers, right? You can see that it's at 30D, and then that's a look ahead. You can tell because it doesn't advance, and then it does advance. because data header is 1 byte, and the next one's 30E, and so it advances again, but then it backs up again. Yeah, let's not print that, but let's print this. We'll print that even if we don't print this one. Okay, then that was in, not here. We're done with that. Here, right? Yes. So it should be if not error and the goal of parsing. Do we have the goal available here? No. That's not known. Well, actually, the parent knows that, though. Hold on. Yeah, this knows it. So I guess, should we pass it there? Another argument. Cell statement dot goal. Parsing goal. This is marked as copy. Oh, it's not. This might get clone and copy. So what we're going to do is we're only going to print it if it's a part, not if it's an ignore or a look ahead. So that implies that I should actually include that information in the callback. So is that what I did in the C++ version of this? Did I use that in the callback? No, we always printed, looks like. We printed whether it was, yeah, so I must have, how do we find that? Current component completion callback. Here it is. That's placing in place back. Cleanup function. Oh. So as if there's no path. If there is a path, then we're going to do a completion. Oh, it's if the size is greater than 0. That too. Well, that means it's a part, right? Maybe it's the complete? Maybe we don't mark it complete if it's ignored. How do we find that out? Final references to complete. It's complete if... What is this? Oh, and that... Okay, I don't want to look there. That's too complicated. Shoot. You know, screw it. I don't care. What's the... Oh, I started writing this, right? And goal is equal to parsing goal part. Okay, so then here it's to parse, right? Okay, and 2 more places. Right, for a function, it's a different goal, right? Parsing goal, I guess it's ignore because it's a function call. And then, yep, okay, so let's see what I get now. Why does it say skipping? Okay, oh, I forgot to do the equal null. That's in the main program thing. So yeah. Yeah, it's 12:30. Need to go to bed. Staying up too late. Not a good thing. Yeah, it's this thing, right? We don't want to print equals that at all. So I'm going to build the equals into if this is something, then we'll do a format equals value. So and we won't print anything. So this will be string new. Okay. Let's see what I get for that. Looks really good. Okay, so now let me pipe that to new.txt. Okay, and now we can diff the old and the new. So that's the old and that's the new. Right there. Old. Okay, it's hard to see. So select for compare, compare with selected. Close this one. I guess it's going to take it a while because there's a lot of lines in the file. Yeah, 55,000 lines. It should see, okay, I don't know why the diff tool is not working, but it should see that the only difference is in the left column. Bummer. I was hoping to get like something better out of this. Well, actually, you know what? I could massage this. I can just remove all text before. Like that's the old one, right? And the new one, it should just remove all text, the first number of columns there, right? Yeah, the diff is struggling. So let's do this. So what's a good way to like cut off a certain number of characters from everywhere? I guess I need to also remove all the warnings. Okay, that's what a warning looks like in the new. What does a warning look like in the old one? It actually just, it says, oh, it repeats that for some reason. Why does it say 5.5 to 11.5? Oh, it's giving all the spans all the way down. Huh. That's a really detailed warning. All the way down, and in the new, I'm only reporting the innermost. You could use kdiff, vimdiff, and others. Okay, well, let's see. What do I have available? Vimdiff? I have kdiff? Don't have kdiff. Well, what if I just do diff? New.txt and old.txt. Then I think it's just, yeah, it's really struggling. I need like a one that can just like ignore the like diff columns, really. Either that or I need to chop off the columns on the on both of them. Like cut. Basically, when I cut everything from me, actually I can do this. Select all. Limited to 10,000. Increase to 100,000. Okay, we're gonna have 100,000 cursors. Ready? We have 52,000 cursors. Delete. Okay, it just took a while, but we're good. We're good. Move to the right. It's frozen. I killed it. Running out of memory, probably, right? Window is not responding. Keep waiting. Weird. Well, that didn't work out so well. I thought my VM would be more powerful than that. It's not responding. Oh, keep waiting. Keep waiting. I think we're gonna have to kill it. Bye-bye. Oh, I can't kill it. Go away. I guess I have to wait until it like, there we go. Reopen. Oh wow, the buttons don't even work now. Time to, oh no, that's the VM. No, is it the window manager? Okay, pgrep. Do I have pgrep? Pgrep code. Oh, there's a lot of code. Grep. Less. Code. There's a lot of code processes running. Which one do I kill? Is this responding yet? Close. Yeah, I don't, oh, there it goes. All right, reopen. Okay, we're back. Well, let's not try that again. What am I gonna do then? I guess I could change both tools to do just a printf instead of their logging technique thing, so that the log message would not show up maybe. Like this is like a log level and a logger and a time. If we just did a printf, it would just print exactly that, and then it would match. Right? It just printed that on both of them, and it would match. I'm considering it. Linux core utils are your friend for text manipulation. Might have a better with a macro for that one. Well, I was just hoping we could have multiple cursors working. Actually, what if it's actually allowing me to scroll a lot easier. What if I just delete one character? It deleted the character, but then it gets stuck after that. That seems like a bug to me. Like it's in an infinite loop somewhere. I think it's stuck in an infinite loop. Oh, no, it came back. So deleting each character will take, what, 30 seconds? Yep. Should I time how long it takes to delete one character? Okay, ready, set, go. Seven thousand, 8,000, 9,000. Thousand and 23. Took like 23 seconds to delete a character there. Yeah, I don't think it's worth it. Just turning off multiple cursors took forever. I mean, it was quite effective. Oh, and undo took oh, undo is actually a lot faster. Okay. So it's not too bad. I should probably change that setting, right? Settings for like whatever. What's set to 100,000 right now? Nothing. Or we don't know. Multi-cursor. Here it is. Can I put that to the default reset setting? There we go. Okay. So how hard would this be actually if I wanted to? I want to look for like the PRI that I was seeing before, like the PRIX64. Yeah, it was here. So it would just be hack this to do a printf, right? I think so. So if I just said printf, that would work, right? So then give me my CMake tools and build again. Okay, and so terminal, let's do this again. Okay, and then look it out at old. Oh, we need to have a new line at the end. New line. Build. Run again. Okay, that's much better. All the warnings are going to still have those prefixes in them, though. Maybe I don't worry about those lines. Maybe the diff tool will make its way around that, right? So let me just make the new one the same way. So that is in main.rs there. And instead of doing like an info, we do a print line, right? And then cargo run. Yeah, exactly. It does do that. And then I have the new. Then I can do the old. Never mind. I go to old and I do select for compare and I do new and I see compare with selected. And it still struggles. That I would think that it would be able to do it. Diff old text and new text. The diff is able to do it. How come the graphical diff can't do it? So I need a better diff tool. I guess the one built into VS Code sucks. The tried and true diff said that it started being different at line 790. And the difference is the extra header part. And the introducer's the same. Yeah, it's just not giving enough context. Anybody have a favorite diff tool? If you're not familiar with the core utilities and you don't want to go deep, now you can just do a dumb search. I was hoping that I would just have an okay diff tool, but yeah. Does your packet manager not have kdiff3? Nope. Meld. Nope. Should I just go and install something? How to remove a column? Well, I think we've already removed the column. We're past that point. The problem now is the I have the two, and see, they look pretty much the same. It's just that they differ like around 700 lines in, and I guess the files are just too long. I mean, they're only 56,000 lines long. You'd think that it'd be able to do that. I ask too much, don't I? It's still working. So, do I have a diff tool? I just don't think I have one. So, what's a diff tool we can try? Okay, I'm gonna ask ChatGPT. ChatGPT, what's a good diff tool for Linux? What is a good free graphical diff tool for Linux that can handle huge files? I've never seen it take that long to think. Meld. It says meld. Okay, let's try meld. How do I install meld? It's just on Ubuntu sudo apt-get install meld. Okay, we're doing it. Sudo apt install meld. That's Rymu. That's the sudo password for Rymu. Oh, maybe I didn't type it right the first time. Yes. So what will work for, what will happen first? Will we get meld installed or will we get the old diff to work? Okay, we have meld. We want a file comparison. I want to compare project, nope, not public, projects, DataDisintegrator, old.txt with, yes, old. How do I pick the other file? Compare. I don't get it. Do I pick two files? I selected the first file. Now what? Compare? Oh, with a new file? Where did the new file go? Old, and where do I put the new file? Why is it showing me not, why is it not showing me new? I don't get it. Home, projects. Okay, I don't know where I was, but I wasn't where I thought I was. Okay, open. Here we go. Looks like meld wins. Winner is meld. Usually do meld F1, F2. Okay, well, I was just dumb and did a change highlighting incomplete. And I had to do it because they were too large. Keep going. You can do it. I believe in you. Okay, so where's the next? Here it is. Nice little buttons. So is it trying to tell me that they're the same-ish or that they're the same? Because they look the same to me. I think because this is a little slightly lighter blue, it says it's that line is not in there. Okay, but it does say, it ends up saying skipping 24 extra bits. It's just that the line numbers are different because it reports a lot more context. Okay, and then yeah, we're printing extra stuff. Oh, or there's also data 0, data 1. We're not printing that here. Oh, okay, that's what I'm missing. See, the old is printing the vector context, and we're not doing that in the new. Yeah, okay. Well, I printed the vector context at the end, but not in the middle. That's the problem. I think I know how to do that. It's before we print this dot, where we have to print the context of the parent. Okay. I guess you can stop. We'll put you in another workspace. Can I move you? Move you over here, please. There. There. Meld will live here. You can live there, Meld. In fact, you can fill my whole screen. Please. There. Okay. You can give up now. Okay, so that would be in context, I think. I shouldn't be up this late. What the hell am I doing? Okay, we're almost done. I just want to see that it has the same output. I really just want to see that. Same enough, right? So here's where we're adding the composite iterations for the part, right? The problem is we're only doing it for so I think the problem is we're doing it here and we shouldn't do it here. We should be doing it outside and we should be doing it immediately on when we where should we do it? It should be whenever we enter a new component. So this composite iterations, right? We should be adding it right here before we do add to path. Path plus equal next. Wait, what? What happened to the dot? Shouldn't I be doing like an add to path dot? I don't get that. That sounds wrong to me. Okay. This is only called from one place, right? Yes. Then what the heck? What is this called from? There. I think I might see what's going on. This new one, right, has a new path in it, and it always adds a dot. I see. Yeah. Why did I do it like that? Well, this would be the place to do it, right? New with part. We're at that's exactly where we're adding the dot. I don't know why I'm doing that there. That should be an add to path, not a new with part. But it does give me the opportunity though. So it would be right here actually. If actually it'd just be for index in why am I typing it when I can just copy it? Like this one, right? Or that one. Am I going to end up printing it multiple times? No. This is a local path. Yeah, I think we're fine. I think we're good. So go back here. Okay. Yeah, let's try this. So what's it? Control Z and then BG to background it. Okay, so then and jobs will tell me if it's there, right? It's running. Okay. So then run this again. There. Scroll down. So now we have the context in there. So now I want to go and rerun. Can I do a refresh? Yeah, reload. It's diffing. Okay, it starts to see some differences there. Oh, the color table doesn't have a 0 in front. So we failed, right? Data. Oh, we put it on the wrong side. It says gif6.data. That's funny. Okay, well, try again. That's close though. So it's where it's not self iterations, it's yeah, this is the wrong spot to put it in. It's the caller of this. Yes, it's right here. Why don't I just pass it in? Because that's what I need. Right here. And then this, actually, I need that back. And then this is iteration, parent composite iterations. Use size, right? This goes here. Cannot borrow itself. Okay. Oh, it has access to itself, so I don't need that. Wait. Then why didn't this work when I tried it a minute ago? Oh, because it's that thing that, okay. never mind. We need to add it after we add the name, then we add it. So it's in the add to path where we need it. Add to path. But I think that by that point it's too late, right? I think that's right, but I'm not sure. This might be comical. Let's see what we get. Yeah, it didn't work at all. Because when we get to the new thing, we don't have that in there yet. Okay, it's before we add the dot, and we have to add the parent. So it's right here, but we have to have the parent's context, which we don't have. Oh, wait, why don't I have it? Why doesn't this work? I don't understand now. Isn't that right? Whoa. Okay, we got explosion. Explosion. That's not right. I think I think I know what I did wrong. It does self path, not path. That's funny. It like accumulated indices. Okay, back to sanity. Okay, look at the top. That is correct now. I think I did it. I fixed it. Whatever I did, I fixed it. So rerun. Oh, I see what the problem is. The old one didn't have it. Well, shoot. Then why am I bothering to add it for the new? Oh, wait, no, it did have it. Dang it. It does have it, it's just in the wrong spot. Yes, I need to, okay. It's adding the one for the next guy. But I want to add it for the previous. The previous context, not the current. I don't have access to that. Do I? Hmm. We only have, okay, shoot. I'm having trouble thinking. So like if we're here, we're creating red. We end up putting 0 because we're in 0 for a loop in color table, but really it goes onto the red, not onto the color table, right? It's almost like I need to construct the path dynamically on every callback, right? I think that's probably how I did it on the C++ code. So let me look at that. composition. I don't know where I'm looking now. Oh, it's just main? Okay, so set component callback, complete callback. Right, let's go in there, and it's this one. Find all that. Okay, so I do have that built somehow. Callers? Render loop context. That's what I called it back then. Okay. Oh, I formed it ahead of time. So I put a dot, its name, and then the the loop context of the previous context. That's what I've been. Okay, I think I see that now. So it would be after this point. So not here, but it does need to go into the add to path. So remove from there. The problem is that it's not available until later. So the add to, well, unless it changes, so add to path doesn't, like it's called too late. It's what it's being, what's happening. So call hierarchy. It's being called here, but really, actually it's passed in, right? So hold on, call hierarchy again. So there's a context, right? Okay, so like right here is where we make a new context from an old one. And then we've formed the name here. And I am passing those iterations on. They're there. Okay, then it's right here I need to do it. Right here. Self.path. Actually, I should just pass this in here, really. That's exactly what I should do. And then this should move into here. There. Composite iterations. Use size. Okay. Did I do it finally? I closed it? Why did I do that? I don't know. Okay, I think we're just now we're printing it one too many times. Yeah. Okay, so that means I don't want to print the one at the end in the callback. So on parse, it's not actually needed. Why is it not finding it? Oh, on part. Yeah, okay. Yeah, so here I don't need this anymore. So I can just use self.path. Okay, and then does that mean I didn't need, so okay, right, I just moved it really. Yeah, and then it's, yeah, okay, that makes sense. Okay, run one more time. One more time. think I did it. I think I finally did it. Yep, yep, I did it. Yep. Okay, good. Good, 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 good. So go over to this workspace, hit reload. It should find not as many differences. Good. So all these extra ones are the look-aheads that we're doing, right? But yeah, and the warnings look different. But otherwise it should match pretty much 1-to-1. Yep. All right. So it's time then for the apples to apples test. So let's go to dev null. And run the release build. So see how fast it is when it's parsing the lol.gif file. Give kdiff3 a try. Meld does not give that many options up front as GNOME is prone to do. It's also way faster in experience. kdiff3, huh? Should ask, how do I install kdiff3? So it's just sudo apt install kdiff3. Well, that's busy building anyway, so let's go look and see if it's better. Sudo, we can move this over here. Sudo apt install kdiff3. Whoa, I need 104 things. That's gonna install like libkf5 everything. That's a lot of dependencies, or driven. Only 31 megab. Okay, so this screws up my VM, then I'll be unhappy. Maybe before I do this, I back up the VM. Hold on. How do I do that again? Take snapshot. We're gonna call the snapshot before kdiff3. Okay, we're taking a snapshot. All right. Now we can totally mess it up. All right, here we go. Working. Installing 103 dependencies. Here we go, here we go. 20%, 30%. All of a sudden my screen gets hacked and says or driven has 1. Okay, so cd projects DataDisintegrator kdiff3 old.txt new.txt. Oh, is there no dark mode? It's blinding light. Where's the dark mode? Okay, I need a dark mode, or else I'm not going to use this. I don't know how to make it not blind me. My eyes, I know it, and it kind of looks the same as... It kind of looks the same as the other one, as Meld. I think Meld looks better for style-wise, because it's not blinding me. And like the first diff, yeah, let's compare that with the first diff of kdiff3. There. I mean, I kind of like Meld better. I don't know. It's interesting the warn does show up in yellow. Is it? Oh, that's because I have it selected. Never mind. Also, the G is getting cut off. Yeah, well, maybe not a fair test. I think I prefer Mel just because it's not blinding me. And it has this kind of cool little graphic here that KDiff3 didn't have. Okay, are we done now? Cool. So I need to run that with time, right? 0.219 seconds. Actually, and a real fair test would be target time, target release ingest gif stage.lul.gif stage.gif.format pipe to dev null. 0.155 seconds total. So time, this one. Rust is faster than C++. So we got the C++ one about 0.216 is the best time so far. Okay, time to time Rust. 0.178, 0.177, 0.175, 0.172. Yep, I hate to say it, but Rust is better. Maybe in settings? I couldn't find the settings. Is that oh my bash? Yeah, it's oh my zish. OMZ. And we haven't updated it in a while. There we go, we updated it. Yeah, when you actually don't pipe it to dev null, it takes a lot longer, right? Actually, what happened? How long is it to if we pipe it to new.txt? It's a little bit slower. And if I run the C++ version, to old.txt, right? Yeah. So the Rust version is a little bit faster. Well, I'm sold on Meld. KDiff3 close second. Definitely better than the built-in one here, which kind of fell on its face, right? Actually, maybe it'll do better now that there's a lot fewer differences. Select for compare. Compare selected. Yeah, it's still like, I don't know. Oh, wait, it's done. Okay, so this is the built-in VS Code comparison. It's not bad, right? It's giving me the same output as this, right? It's built into VS Code. It was a little slower to start. It falls on its face if there are too many differences. That's the thing, right? And yeah, we're gonna get a lot of warnings when we skip the data blocks. It compares all the way to the end of the file, and yeah, all the substantial things are the same. Cool. All right, I'm gonna head out. I'm not sure what I'm working on tomorrow because we have parity with the C++ code. I guess we're just no. I guess the next thing would be to start scripting the thing, right? So I've done a little bit of this in the C++. I forgot how far I got though. But the idea would be that you could write scripts in Lua that would operate on the actual data. So like I had written like, yeah, Lua adapters for stuff. So like converting between Lua types and DataDisintegrator types. I don't think I have any example scripts lying around though. Yeah, I've just had like some like a Lua, there's like a Lua finalizer, read index, new what is this, for a bit stream? Yeah. Lua new meta table, all this stuff. So the idea would be to like take the types that are built in Rust for the output and let you run a script on them. And then the script would be like another thing you could plug into the GUI. You know, making something like this, right? That we not only drop in data and we drop in formats, but we also drop in Lua scripts. Like KD, but it didn't force telemetry or something. I don't know. Is this XFCE? Yes, it is. Does it support fractional scaling? I don't know. Yeah, I'm using this OS Xubuntu. So this is something I wanted to look into, like, because Lua scripting allows me to like quickly like attached to every format would be like scripts that work with the format and the data once it's parsed, right? And then we can do GUI stuff. Okay, we're done with this guy. Bye-bye, Meld. All right. I think I'm done. Send that out of the virtual machine so I don't lose it. What did it end up sending there? Oh, it's the new and the old. Okay. Okay. Yep. Gonna call it. What do I end the stream on? I guess we'll just put it on the, yeah, let's just show this, and now I can show this again. Cargo run. Well, I just want to pipe that to less, right? There we go. Or one character too long to show that. Well, actually, it's showing the 300 now. Oh, I need to repair it so it's going back out to the log system. I can't forget to do that. Well, anyway, you can see our data being decoded by our decoder now. I should be working tomorrow on this some more. Maybe do some scripting, maybe some introductory UI work. We'll see. Can't raid Musin. I wish I could, but I guess we'll go see Evan then. Oh, it will let me raid Musin? No, he doesn't accept incoming raids. All right, try again. We'll try Evan. Okay. Evan's working on his own MMO, I think. Although it kind of looks like he's just chatting right now. So anyway, have fun in his stream. Good night. Have a good day. Bye.